Let k be any positive integer. Explain why there is a positive number such that n root 2 root 3 r is equal to k. So this function n was described earlier. So, r. This represents the number of points inside a circle centered at root 2 root 3 that are a distance away less than or equal to r. Okay, so we need to explain why for any positive integer k there is an r that allows there to be k points. Oh, sorry. I was thinking it was points on the circle, but it's not. It's points inside the circle. So basically, this is equivalent to showing that we can find. Yeah. So this is combining again with a previous result. That if. Okay. So let's let p be equal to the point root 2 root 3. Okay, so if q is equal to m and n, mn integers, and let's call this q1, and q2 is equal to capital M, capital N, again, both integers. If the distance from P to Q1 is equal to the distance from P to Q2, this implies that Q1 equals Q2. This is a result from a previous part of this problem that I worked on in a previous video. So this shows that this shows that for any distance, there is only one integer grid point. There is at most one integer grid point that is that distance away from P. So for any r, there is at most one integer grid point which is distance r from P. So what this means is that if I take the function f of r equal to n root 2 root 3 r, I mean, f is an integer valued function, though, because of the way that this function n is defined. As I increase r, I'm taking circles of larger and larger radius around this point, and I'm counting how many grid points lie inside that circle. So because f is about counting grid points, it's always an integer, but this property is saying that this function can only increase by one at a time. It can never jump up by more than one. Yeah. Yeah, so this was, again, relying on previous results that I had solved before, all part of one large problem on this exam. But I thought that I would break it up into subparts. Maybe in the future, I'll just do all these as one longer problem. Anyway, that's the end of this one. Thanks for watching.